Shall we start now? Almost everyone joined.
Yes, sir.
Okay. Can, so is my screen visible to everyone?
Yes, yes.
Okay, we'll start. So in the yesterday class, what we have done is we are setting up the model for the rational method. So we read the grade file and create catchments. Then we place the gullies. Then we made catchment connections through GIS. Then we connect the gullies to manuals through JS by creating that join by attribute. So after that we'll be going to set up design constraints and catalog for the model. After that we'll be running the model. So in the today's class what we'll be finishing is whatever we left over in the last class we'll adding that one also. Then we'll be seeing how to use specify local pipe constraint and how to give point load to the manual and gullies, then how to differentiate the catchment using some specifications like CN number or time of concentration, anything what we want to differentiate in that way. After that we'll be seeing something difference between scenarios, options and alternatives for the dynamic method, how to use, how to play with the scenarios and options. So we'll start. uh, this is what we said yesterday. Like we have imported the catchments, we have imported the gullies, and we have imported the manual, and we have connected everything. First I will change. So if you go to home, there will be some drop down option here. If you click this means we can change the background, like if you want to see in white color we can change it. Okay. So in yesterday what first thing what we want to see is design constraints. So in the first class itself, I have briefly described how to use these design constraints. So for this model, what we are going to do is we're going to set up the design constraints for the conduit as well as the inlet. So go to analysis tab, go to design constraint. So for the velocity, we'll be setting up like 0.75 as the minimum and 2.5 for the maximum. And for the cover, this is like for the manual cover and the inlet cover. So if you are not specifying anything particularly here in the table, it will take for a common thing for both gullies and manuals. So we are going to give common values for the minimum and maximum. For the minimum we'll be giving 1.2, for the maximum we'll be giving 10. And slope. So this is also same thing. If you're not specifying anything in the table, like for the 315 pipe, so the minimum maximum should be between 300 and 400. So for the 400 pipe, the minimum maximum should be between 350 and 450. If you define something in this way, it will take the surgeons will design the model in the table what value we are providing. If you are not defining anything and simply putting like this, like 200 and 1000, so it will design based on this only. So better to go with the table. 450, 550. Yes.
Yeah, what is the difference between between 200 to 1000 or segregating like this?
No, I'm not getting you exactly what you're asking. What is the difference between?
Are you giving the table values or simply between 2000, 200 to 1000?
Yeah, okay. The simple value what we are giving here now, minimum as 200 and the maximum as 1000. So what we're going to use is we are going to design for the whole network. So in the whole network, the based on the flow, the pipe may differ. So if you are giving steep slope for the bigger pipes, means it is not efficient design. So I will show this one. Go to conduit. So we are going to use this much pipes in this area. So based on the flow, it will automatically choose the pipe size. If you are not specifically mentioning the slope, like for the 315 it should be like 300 to 400, it will automatically take like 500, 600 something, it will be huge. So for the lower pipes we can go for steep slope. For the bigger pipes we can go for the mild slopes. So for that purpose only we are defining here. So did you got Abhinaya?
Yeah.
So after 600 we can better to go with same slope. So we have set it the velocity, cover, slope. This one is not needed right now. After that, this is for pipe constraints. So now we are going to do for nodes, which is like gullies and manholes. For the nodes pipe matching, we need to go for crown to crown matching. So first we will do with the allowed drop structure. After that I will clearly explain with the profile how it works and what are the things needed for this. Then inlet. So maximum spread is 2.4 and maximum gutter depth we are going for 0.15. So here we need to mention like minimum efficiency of the grade. So efficiency of the grade is like how much percentage efficient that gully is. So this is one road. Here one gully is there and here one gully is there. If you are putting 50% as efficiency, means so the water flowing from this side, like some amount of value like 10 meter cube, consider 10 meter cube volume is coming to this catchment. So the 50% will be go inside this gully. The remaining 50% will be flow to the gutter and follow to the next gully. So for that purpose only we are going to mention here. Here I am mentioning 60% as in efficiency. So first is design constraint is over for conduits and nodes. So then we need to set up a catalog. So
Venu, can you go to design constraints again?
hello, what?
Venu,
Huh?
can you go to design constraints again?
So, yes.
So it's part full design on the right side.
Yes.
This will still percent, no?
Yeah, this should be check in. Yes.
This will be checked and it will be 100% for all the
Yes.
pipes.
Yes. Yes. So the part full design also need to be checked in here. So now the design constraint part is over. Then we need to go to set a catalog. So go to components, catalog. So the purpose of catalog is like if you have some specific pipes and specific material you want to use that particularly in your design. Uh, for that purpose only we are specifying this catalog here. So how to create a catalog? So go to here, click. So I'm creating a catalog for gully pipes. 200 available for design. Here PVC, select it. So here you can rename for your convenience, like gully pipes. So we have set a catalog for gully pipes, and we have set a catalog for the all the pipes. So based on the how much volume is created from the catchments, it will automatically take the pipe, required pipe. It automatically take the required pipe. Okay. If you want to use specifically one pipe dia in that particular space, we need to create a catalog for separate thing. Okay, like 315 na. So I just want to create some 400 pipe in one place. So for that you need to create 400 inner dia is 400. So here also we need to mention the inner dia. It should be 190.5 something. Available for design. This is number GRP 400. So this is how we need to set the catalog. So here make sure the conduit type is in a circle. So to run the model, we have set everything. So we need to ensure that whether it is added in the attribute table or not. So go to, first we'll check the conduit, edit group, go to conduit table. See here conduit type, material, size, catalog class, and design constraint. So these are things we need to ensure that whether it is in correct format or not. Everything need to be checked here for the design conduit. So then only it will design. So then here we need to check conduit type. So there will be two options. One is user defined conduit, another is catalog conduit. So we have created the catalog, so we are going to use this catalog. If you have not created the catalog, we can use this user defined conduit here. So automatically the options will change based on the requirements. So we can define the diameter here, whatever you want. I am going for 400 for all the things, means I can define here. If I am going for something for the particular conduit, I am going for something like 300 and 200, means I can mention it here. But we have a catalog here, so we can go with this. So then initially we need to set some size. So we need to set we have multiple diameters for the initial setup of run. We need to set some size, like anything. After, based on the runoff, it will automatically change. Okay. So content catalog, everything is okay, but here one thing we need to ensure that we have two different pipes. One is for main pipe, which is connecting manual to manual. Another is gully pipes. So we need to differentiate this. For that, while importing, okay, something is missing. We're going to take gully pipes as a separate selection set, and we'll be giving separate values for that. Okay. Conduit table, go to edit group, conduit table. So based on the length, we can differentiate now. We have no other options for this.
But you can segregate using the labels here.
Labels.
You know, just sort the labels, ascending to descending. So PO or
Okay,
the
yeah,
manual.
okay. Got it, sir. G. Okay, based on the labels also we can sort it. Yeah. So this is like main pipes. See, the red colors are in main pipes now. So we are going to create a selection set for this. Then gully pipes. Gully pipes, we can ensure that whether all the selection set is proper or not by clicking the main pipe selection set. Main pipe is selected. By clicking the gully pipe is selected. So right click, edit group. So if you want to click specifically for some, if you want to check for only gully pipes, we can use the selection set, like click the selection set, right click, edit group, conduit table. So only selection set for gully pipes will be open. Here we can choose like so for the gully pipes we have graded 200 mm material, so I am going to choose that one, GR PVC gully pipes. So size we need to change 200. Before size we need to change the catalog here. So catalogs are interconnected with the size 200, then size 200. So now we have set everything for gully pipes 200 mm. Then what we are going to do is for the main pipes we are going to set. Go to conduit table, all pipes, all designs are okay. Size we need to select this one. Okay. Materials need to be selected for all the things. GRP. So now we setted everything for gully pipes, main pipes, and catch basins and manholes. So for the catch basins, I didn't show now. Okay. For the catch basins, we need to set. First, we need to set the catalog for the catch basin. Components, catalog. First, initially we set the catalog for the conduit here for inner pipe and the label. Based on the material, it will come. Same way, we need to set the catalog for the inlet catalog. So initially, I have set it like top entry and side entry gullies. So for the top entry, we need to how to set this catalog means click here, enter top entry. If you click this, this will open. Here we need to set which type of inlet we are going to use, inlet type. So if it is a top entry means we need to use the grate. If it is a side entry means we need to use the curve. So for the top entry we need to use click grate. So the structure with structure length is 0.6 and the grate width is 0.6 and the grate length is about almost 1 to 1.5. So that is what I have mentioned here. So after setting this, there is one more option in design. So in the design, we will ask for design length. So here we need to defaultly we need to give 1. So that is the same thing for we need to do for side entry. Curve, we need to set everything like these are the values 0.6. Curve length will be 10 centimeter. Then local depression depression width is like two roads. We having consider one road, consider one curve like this, and road is like same like this, but we having one depression here like this, near to that inlet. So this depression width and how much area is depressed here near to that gully, we need to mention. If there is exactly the depression is there, means we can mention that, but for us we don't have any depression here, so we are making as 0 and 0. Then close it. So we have set up everything for that pipes and nodes. Then we need to move on to catchments. So for the catchments, the runoff method will be rational method. For the rational method, we will be giving two inputs. One is runoff coefficient and another is time of concentration. So go to edit group, catchment table, maximize this. So here we can see. So we need to choose this. These tables should be on here, like runoff coefficient, runoff method, time of concentration, and user scaled area. So right click here. If there is some other runoff method is chosen, means right click, global edit, value. Here multiple runoff method will be visible. Here we need to choose the rational method. So it will change here. So after that, based on the plots and roads, we need to give the runoff coefficient. So for as of now, I have given for the plots 0.5. For the roads, I am giving 0.6. So time of concentration is standard based on the standards. So another thing I need to mention here is scaled area and user scaled area and scaled area. So we'll change the units to meter square. If you are using same area what the plot is giving, like so consider this plot P plot 29. Okay, this plot area is 407, but someone is going to tell like make use of 50% area of plots and 100% area of roads. So in that case we need to check in this. If you click this here, no, it's already like this only. If you are going to use that one, means we can mention it here, like this is for the plots, and we are going to take 60% area only. Okay, so for the plots, copy here, paste it. So in the everything other things need to be used, what are the area is mentioned in that, mentioned in the shapefile itself. Okay, so please check this. So this will be closed. So for this area we need to use 60%. Go to global edit, if you are dividing by 2, yes,
Hello.
yes,
Why we are considering 60%
just
for
I am
that
telling this
particular
option is
catchments?
available in CVGems, how to make
Okay, you are just telling for an
yes,
example,
yes,
right?
yes.
Okay, fine.
So for now we will take 50%, so that will be more easy for that. If you want to add something, we can add it here. If you want to divide something, we can divide it here itself. No need to go for Excel and make the calculation and come it back. We have CVGems, we have convenient options here like this. So if I divide by 2, 50% area will be considered. Okay, so see here the options are changed from 324 to 162. So for now we are going to take 100% of area, so we'll check this. So this will be closed. The areas which is mentioned here only will be taken for the model. So everything is set. Then so before running we need to set some annotations to the model, like cover level, invert level, and depth. These are the annotations needed for the nodes, and for the pipes, diameter, stop invert, and slope. So for the catch basin, we're going to set the annotation cover level, elevation ground, CL, okay, elevation invert, IL, -1. So I'm giving this, see, these values are adding here, na, for the inlets and the manuals. For manuals it won't have been, because we are adding annotations for catch basins only. Hello, yes. Yes, sir.
You see the inlet catalog, but you didn't fix the side entry or top entry, no? For each gullies.
That one I didn't show. Okay, I will show. So right click, edit group. So after making a catalog here, we need to ensure that this has been fixed with our model. Okay. Edit group, go to catch basin. Here we can check. So they will ask for inlet type, inlet location, grade length. So these are the options we'll be asking if you are adding the catalog here. So if you are using for there are multiple options here. So as of now, using catalog is the best option. So we are going with the catalog inlet which we have created. So we'll click the catalog here. So then we need to choose which catalog need to be chosen. Like we have created two catalogs, top entry and side entry. So I'm using top entry here. So on inlet locations, so as of now I'm using INSAC because we need to add gutters. If you are going on on grade inlet location, we need to add gutters for the every gullies. But if you are adding INSAC means there will be no escape of water. Whatever the water collecting from the so consider one road, some plots here, here on gully and here on gully. If you are adding INSAC, you are connecting these two plots to this and two plots to this. So there will be no excess of water here. So whatever the water coming from this plot, it will be coming inside to the inlet and traveling to the pipe, traveling to the main network. So this will be connected here, na? One manual. This is the INSAC case. It won't. There is no escape of water. If you are adding on grade instead of this, on grade means we have given like 60% efficiency. Do you remember in the design condition we have given 60% efficiency? So whatever the water coming from this area, so maximum of 60% will be come inside this inlet and travel to the manhole. So then the manhole will carry the water. So excess of that 40% will be excess now. So that will be traveled through the gully to this inlet. So collect it here, and that will be, this inlet will carry that water to that manhole. Then every water will travels in the main network. So that is the difference between that. So here we are using a INSAC. Okay, sir.
Yeah.
Yes, Surya.
Yeah. This INSAC means 100% water will be collected in particular gully.
Yes.
And on grade means some amount of water.
Whatever we are mentioning in that design constraint, na, like 100% means it will take 100%, but we will mention like 60, 50 like that.
Okay. But that means INSAC, and on grade means some amount of water will be transferred to another gully.
Yes.
Okay.
So almost everything is done. First, we need to check whether the rainfall is added or not. So before that, we need to know how to add the rainfall. So go to home, storm data. So for the rational method, we will be using user defined IDF table. Right click, new, user defined IDF table. So in that, this cloud will add the return period range, and this cloud will be this table will be adding the duration. So that is what I have added here. So this is the IDF table which I have taken from online only, like this manual is available online, which I have shared already. So this table only I have created that there. So we can ensure like over the time the intensity reduces. This is what the curve should be. So now we added the rainfall. This rainfall need to be added to our model. So go to alternatives, check for rainfall runoff, change the name like to at what return period we are running. So we are running for 5-year return period. Rename it rational 5-year. Double click. So here they will ask global storm event. So if you drop down, we can see these are the multiple return periods which we added there. So I am going to choose rational 5-year. That's it. Then we need to check this is in scenarios or not. Go to scenarios. So this is the scenario tab. If you double click, go to rainfall. Here the rainfall 5-year is added. Okay. Change this to rational. Now almost everything is set. Just we will checking whether we have given values to the outfall or not. Outfall cover level, ground level is not given. So the nearby cover level is 37.4. So here we are going to give 37.5. For this 36 we have given. So create annotation for that also. Outfall annotation, elevation ground, CL, okay. Then add another annotation for elevation invert, IL to minus 1.5. Depth. For the depth we need to add depth structure. There are multiple options: depth node, depth structure elevation. We need to add depth structure. For the manhole we didn't add it. For the manhole, elevation invert, IL to minus 2.5. Okay, almost everything is set. We'll validate it. So before computing anything, first we need to check whether it is working or not, clear the errors, everything. First we'll validate it. It's showing there is no gutter leaving this on-grade basin. Bypass flow is directed to the sub-network outfall. This is because of we have given on-grade, because instead of giving inside we have given on-grade. So go to edit. So this is this error is because of catch basin. So go to catch basin. We are given on-grade. So right click, edit group, make it as inside. That is not a warning. If you draw gutters to every gully to gully, this warning will go. But we'll be using inside right now. Validate. Conduit does not meet minimum cover constraint. This is just a warning only. There are one isolated node. Be sure all nodes are connected to a pond or outfall link. So if you double click, one isolated node will be available. This is like nothing is connected to this node. So for our model, this manual is not needed. So we will be deleting this. Validate. Okay. So almost all the errors gone. So if you compute, this error also will go. Compute. Current physical alternatives need to be checked. All. Width of the ponding exceed the maximum spread for this INSAG inlet. So this error is due to analysis design constraint. So in the inlet we have given the maximum spread here 2.4, which is not sufficient to our model. If you are increasing this, means that warning will go. We'll check. We'll be putting 5 meters. Simply for your example only I am putting, but we need to put 2.5 only. See that warning went gone. So this is how we need to set the rational model, everything. Can anyone summarize what are the steps we have done in the rational method? As of now, what are the steps we have done and how we are getting the results? Surya?
Actually I have skipped the first lecture, so
Okay,
means
okay.
it will be unable for me.
Okay. Okay, myself will tell. First we have read the grading file and we have created the catchments. Then we placed the gullies based on every 25 to 40 meter interval. Then we created manuals for the gully connections. Then we connected the gullies and manuals using GIS. Then catchment connection also were done in GIS. Then we set up everything like design constraints and catalog for gullies, manuals and catchments, and we have created everything. So finally we have run the model without any error. So this error is this warning is just nothing, no issue for this warning. Then we will see profile. Go to this new profile, select from the drawing. This profile is too steep. See, because of what? See the profile. This profile is too steep because the slope has taken as 300 which is already a steep slope. Then the invert level is not calculated, because of that only the steep slope happens here. So we need to fix that. First we'll check the options whether it is in design or
The
analysis.
unit.
Yes.
Check the units for the slope.
Okay.
It's meter by meter. Could be millimeter by meter.
So because of the unit error, it went that much steep. First validate it. Sembaram, the invert level is calculated here. For the manuals it went to minus. Go to manuals. Elevation ground. Elevation invert. Depth. Diameter. That's it. So here need to check design is on or off. Design structural elevation. Everything is okay. Initially we'll set something, after that only design works. Initially we'll set like 0.12 global depth, subtract. So initially we are going to set like this only. So after running it will, these values will change. So 0.20 is here. Same thing we need to check for gullies. Elevation ground, elevation invert, so gullies are already designed based on that 1.39, but we'll change once. Global depth, subtract, and validate it first. Then we'll be getting conduit start with maximum carbon strength. Check options. Design is on. Still steep.
No, check the slope.
Huh?
This is still check the slope. 0.3, 3 mm per meter. Check the guidelines. On the guidelines,
I couldn't hear you, sir. What you're telling?
the slope is very steep. It is shouldn't be 300 mm per meter.
Ah,
It is somewhere 3 mm per meter. It's like that.
3
Check
mm
the
per
slope.
3 mm per meter.
Check the slope guidelines. Check the guidelines. In DM manual,
Actually,
check how they
in
have given.
DM manual,
They have,
they would have mentioned anything, I think so.
if they have given percentage slope, give it as a percentage slope.
Okay. So, okay, is my screen visible? The slope is 1 by s. That's the mistake we have done. When it's save it, validate it. Inlet type should be set to valid catalog. Inlet opening should be designed. So content does not meet maximum cover constraint. So this is like manual is 1.2 cover is not achieving in all the places. That's why it's showing. So now we're going to run. Now we'll see the profile. See, this is how we need to design the network in the rational method. Okay. Yes, Abhinay.
Yeah. So what is that 1 by S?
1 by is slope, unit for the unit of the slope. Like many people will these are the units available. If you are familiar with the percentage, we can go with the percentage. So I am familiar with 1 by S. Instead of that only, I mistakenly click that mm bar n. So if you are familiar with the percentage, we can go with this, like 0.33, 0.3. So that's simply a unit, Vinaya.
So it's 1 by S is it's basically 1 meter drop for 50 meter of length.
Okay.
It's like that.
So if you are considering a graph,
Yeah.
so for 1 meter there will be a 300 drop like this only, sir. Like this only you are telling, Vishal sir.
Yeah. If,
For the every 1
if you
meter
draw it,
there will be a 3
yeah,
uh,
yeah. Say if your slope is 1 by S is 300, that means for 300 meters, you will have a 1 meter of drop.
1 meter of drop. Yes.
Mm. And it should be, it's not a rectangle, it should be a triangle.
Uh,
Okay? From there, you draw
yes.
S. Your length will be 300.
Okay. So did you got Abhinay?
Yeah.
Okay. So now what we have done is we are simply given the inputs like setting the what are the standards available. We have simply set the design constraints and the catalog and all. So automatically it has designed the network. See, this is the one profile. Yes, yes.
So after assigning this catchment, gullies, and manhole, so based on the area calculation, it is automatically uh, load is assigned to
Yes, yes.
gullies and manhole, right?
Based on the runoff generated from the
Exactly.
catchment.
Okay. Based on time of concentration, based on area of the catchment,
Based on rainfall.
load is assigned. Load is assigned to gullies or manhole.
Load is assigned to the. It's not
Gullies.
like a load. It's kind of rainfall is applying to the catchment.
Okay.
So
Okay.
it's these are the plots and roads now. So the rainfall is applied here based
Ah,
on some calculation like CA by 360. That is the rational formula.
mhm.
The runoff will be generated.
Mm.
That will be transferred to gully first. Then the
First,
based on the
then manhole.
based on the gully efficiency, whole water will be transferred to the manhole. Otherwise, some amount of water will be transferred to the next gully. Some amount of water directly transferred to the manhole.
So, so this calculation is based on the rational
Yes,
formula.
yes,
Q is equals to CI.
yes, yes,
Okay.
exactly.
Okay. Okay. Thank you. Thank you.
So we'll check the another side of the profile also. Go to new, select manual, this outfall. So see here, based on the allowable drop structure which we have given here, na? Design constraint node. So because of this allowable drop structure, the profile has been created like this, like creating automatically a drop, avoiding dig of avoiding digging. It has automatically created a drop in the multiple places. So if you see this profile, this doesn't look nice. So we need to smoothen this profile. So how can we smoothen? Now we can't simply drop this whole manual here and we can smooth it like this. Yes.
Can you just go open the engineering profile once?
Which for the profile 1 or profile 2? Which one you are asking?
Any profile, just open the engineering profile. So. Yeah, okay, go ahead.
Okay. What do you want to see in this? If you explain means others can get to know.
No, I was just checking if the drops are there here, and also if the inverts, the crown to crown matching is happened or not. Just zoom in. Yeah. Come to your left. So which is this profile? Can you just show me in the layout?
This first one here.
Okay, now go to the profile.
Normal profile.
No, engineering profile. Engineering profile. Okay, come from left. Start from left. Okay. So here the diameter is changing. See, come left. Come left. See here the diameter is
Yes,
changing from
yes.
600 to 700 or what?
500,
500 to
600,
600. Just move those. Yeah. See here
700.
there is the crown to crown matching has happened here. If you
Yes.
can see,
Ah,
see you can show it here. Yes. These are below is the invert, above is the
crown,
crowns.
crown. So that is more visible here itself, no? Crown to crown
Hmm.
matching.
Yeah. Yes.
Okay. So this profile is okay, but when we come to this profile, so we having multiple drops in multiple places. So by visually the profile is not good. We can check the length also here. See the length of this area is about 23 meter. Here 69. So here the link length is available. We can see here 23, 69, 82, 86, 77, 14.5. So simply we can create this manual by dropping here and making a profile. So as of now what we can do is we can make these three profiles smooth, like manual MH5, MH6, MH7 can be here, and we can create a drop here, like connecting this MH9, MH12 to this outfall. So now the profile is like this. So what we're going to do is we're going to drop these two, like here, like this, and we're going to make one drop here. Then we're going to make connect this to the outfall, ultimate outfall. Let's see how to do this. So we need to match this manual to here. There are multiple ways of doing this. First I will do in the hard way. Okay. Make a note of this. MH7, MH6, MH4, MH6, MH4, MH5. Go to MH6. This one is MH4. This one is MH6. Okay. So this manual is here. We need to connect this invert to this manual. So it will automatically design this invert. Click this conduit. First, I just want to show the options. So if you are designing automatically by using the rational method, we need to ensure that these things should be in true, like design constraint, design start invert, design stop invert. If you don't want to design this, means we can simply turn it off, and we can make the changes here, and we can do the things whatever we want. So what we going to do is we are going to do everything in rational only, so it should be in true. But here we going to edit the stop invert of this conduit. See conduit 8. Okay, so we're going to put false here. When you come down, there are two options: set invert to start and set invert to stop. This is nothing but this conduit start should be start with the manual of this manual invert, MH4 invert. If it is a set invert stop true, means this invert will be connecting to this MH6. So I will show this. So I will going to make true of set invert to stop. So this is the stop invert, this is the start invert. So click the stop true. So this is connected here. Okay, if you run this, means to match the slope, it will automatically, this manual will drop. Let's see how it's getting dropped. Run it. So to achieve the slope, we are getting on drop here. So like this we can edit the slope and smoothen the profile. So now what we are going to do is we are going to match this manual to this MH4. Okay, so go to MH4. This is MH6. This is MH5. From MH5 to MH4 we need to click MH5 to MH4. So this conduit, go to design stop invert, false, then set invert to stop, true. So we are designed like this. So if you run, means this will get changed. So this is how we need to smooth the profile. Whenever we are doing profiling, make sure the grounds and grounds are matching. These are the grounds. The top surface of the pipe is ground and the bottom is like invert. So this ground is matching. So here we are getting match. So now what we are going to do is we are going to match this with this with this. So instead of turning off design constraint and turning off design constraint and design invert and turning off on set invert to stop, we can use another way. What is this means? We can set the cover level of this. So this is the conduit, conduit 11. So this is the MH9 manual and this is the MH11 manual. See, so for this conduit we are going to reduce the pipe size. So what is the difference? We will see. We'll check the invert of this. Invert of the manual is 11. Invert of the manual is 32.89. First we'll keep it in the mind first. This is 32.89 and the invert of the manual is 9. This invert is 33.4. So see the difference. So difference is 0.5. So approximately if you reduce the 0.5 of the cover, means it will automatically match here. So what we are going to do is there is one more option called specify local pipe constraint. So instead of giving the design constraint, go to that conduit, turn off this design, this specify local constraint. So design, put it as true, so make everything as true. What is the specify local constraint is, we are setting some design constraints for whole thing. For the whole project we are setting this design constraint and catalogs. So if you want to design some if you want some content need to be like based on your criteria, means we can change it here. So I want to change this invert level. So what's the diameter is 800 and the slope we are getting is 800. So we don't want to change anything there. Slope is minimum slope and maximum slope is 800, so it will automatically design for 800. First we'll fix this ground 0.75, which we have already fixed in design constraint. Now same thing we need to specify here. So here previously in the design constraint what we have given is 1.2 cover. See here 1.2 cover. So for now what we want is 0.5 is extra. So for that I am giving 1.2 plus 0.5 is 1.7. Maximum is 10. Then part full design true 100%. That's it. So first we validate this, then we will run. See, this is how, these are the two methods we can make the ground. So what we have previously told is so something happened here. See, some changes are happened here now. So we need to check that. 4 to 6 manual. Four to 6. Design stopping mode is off. Design starting node is true only. Design stopping node is false. Okay, so that we can connect it here. So the issue is with the design then for the MH7 and MH9, seven and 9, design stopping mode false. So this is how we need to smoothen the profile. This is what we have discussed in starting itself, like MH5, MH4 and MH6 and 7. need to be aligned it straight. Then we making a drop here, and we are getting connected to the outfall. So this is how the efficient design should be there. Now, any questions from this? Yes.
You know what will be the cover for gullies?
For the gullies, we can go for 0.6.
0.6, huh?
Yes, but
If you go to your model,
here we have given 1.2 as 1.2 for common for everything. Design constraint.
but it should be 0.6, no?
Yes, yes.
It will be
Yeah.
0.6. Okay, no problem.
Here we have given simple
And
now. That's
I
it.
will tell you one more method.
Okay.
I will tell you one more method to smoothen the profile
Uh,
and match crown to crown. Okay, go to any one of your manual profile,
okay.
any one profile.
Manual profile.
Open any one
Okay.
profile. Say here you want to set crown to crown for MH7.
Okay.
Okay,
MH7. Okay. Yeah,
go to MH7. I don't know if this works or not. I'll give it a try. Yeah.
okay.
Open MH7 here. Click on true for the local pipe matching constraints.
Okay.
Yeah, pipe matching to crown.
Okay.
Allow drop structure false. Run your model now. So this what happens here is MH6 will come down
Okay.
to match with
MH9.
MH7. Run your model. Check. Yeah.
Despite.
Right. You can do this as well.
Okay. Okay. There are three methods. So thanks for telling this.
And you have to make sure when you're doing this, okay,
Uh,
so the gullies that you're connecting,
that also will go down. Huh?
yeah, so that you have to turn off the
Yes. Yes.
what
Here, see the depth. It went to 2.3.
yeah.
Actually.
So while doing that,
Ah.
click on that pipe, that gully pipe, double click on the gully pipe.
Okay.
Here you have to stop
Design.
the design stop. This should be false.
Okay. Okay.
Design stop invert should be false.
Okay. Okay.
So that 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 depth will not increase.
Okay.
Previously, I think it was 1.3. It should remain 1.3.
Yes. Yes. Okay. So.
Make sure that
Uh,
you do this.
okay. Okay. Thank you, sir. So, do you guys understand, right? There are three methods of doing profile smoothing. One is by matching the invert. Another is by giving the cover level, clicking the specify local constraint and giving the cover level. And the third method is like clicking the manual, going to that local pipe matching constraint to go to the pipe matching as crown to crown, then make it the allow draft structure as false, then it will automatically match the profile. So now we have seen how to smoothen the profile in three ways. So this is how we have created. So this is a nice profile. We can see the diameter, slope, and ground level, invert level. So next is how to give. Okay, Vishal sir has told like if you are doing this profiling, we need to check the gully's depth and gully's pipes. So we need to. For this, what I am going to do is I am going to turn off the gully pipes and gullies design. Go to edit table, catchment basin. Here you can see the gully depth is like 1.39, 1.39. That is huge for gullies. So what we are going to do is select all, paste it here. globe let it subtract to 0.6. So here every gully's may has become 0.6. Then go to design, search for design structure elevation. So here after no need of structure elevation because we have already fixed the gullies to 0.6, so we can uncheck this. If you see each gullies, every gullies are in 0.6. Okay, then go to design constraint slope. We didn't add anything for gully pipe. So whenever we are adding this design constraint or any slope, any table, it should be in ascending order. So otherwise it will show some warning. Like here we will be adding 200. So the pipe slope need to be 200. So what now we are doing is we are setting the gully depth to 0.6 and making the pipe slope to 200. Okay. Just first understand what we are doing, then only we will get to know what are things is happening in the model. So we will set the minimum slope or maximum slope, close it, validate it first, no validation issue, nice, then run the model. Now selection set, gully pipes, edit group, go to conduit table, check for the slope. Slope calculated is 1 by s. What happened? Here it should change into 200, but it's showing like 30 because of some you can search for design start invert, design stop invert, make sure everything is on. Slope calculated is 11. Actually when it comes to stormwater, there is gullies are like not much important in the design because based on site condition only they will place the gullies. So make sure that every gullies are in 0.6, that is enough. The connecting pipes are like based on site condition they will connect it, but here it should come 200, but I will search and tell you later this one. Next class I will be telling why it is not coming 200, because it should come 200. Whatever we are giving, it should replicate here. Okay. Yes.
Go to your gully's table.
Huh?
Flex table. Go to your gully's flex table once. Conduits. Only gullies. Just select gullies only.
Actually, whatever we are fixing in the design constraint, it should replicate here, but we are making that depth into 0.6 now. So because of that only, it's showing. Because of the depth constraint, it's showing in the slope is not getting into 200. It's restricted to this small amount of slope only. So we can check that one also. We will check like.
That is very steep slope. Check why it is happening.
Yes.
Very steep. I think it's trying to match the
cover depth, something is trying to match, but I'm not getting exactly. We can try by giving 1.2 cover for that.
You can check that and let us know in the next.
Okay, we'll continue. After that, I will check and let you know. Okay. So what we're discussing, we have set the rational method. Then specify local constraint. Okay. So see the profile. So here like 500, 600, 700, 800, 900, multiple variation in the diameters. But I want everything need to be in some certain like 700. I want every pipes need to be in 700. So for that, what I want to do is select this profile. So if you select this, if you click this highlighted profile, it will show which is highlighted. If you click this one, means that line will be selected. We can go to that conduit, edit table, conduit. We can use specify local pipe constraint for this. Specify local pipe constraint. So if I am giving this as true, means some option will be closed. As of now, nothing is closed. Specify local constraint to true. So for this switch manual, if you click here and click this select in drawing, so the object will be highlighted here. Go to this. So these are the constraints we need to give for this manual. First we'll open in the attribute first. Design constraint start stop, specify local constraint true, then part full design. So while doing first time only, this much complication will be there. If you set everything, next time and all, just clicking the button only. Part full design. Then what we need, measure cover 2. Then velocity minimum, maximum, cover minimum, maximum, same, cover constraint minimum, cover constraint maximum. Then slope, maximum, minimum. Now we can change whatever you want. Like I am giving, what I want to do is I want to change every pipe diameter into 700. Okay. Specify local pipe constraint. Here there are two methods of doing. First I will show this one, pipe ground to ground matching. Maximum should be 2.5 meter per second, minimum should be 0.75, and minimum cover is 1.2, maximum cover is 10. So anyway we are going for 700 mm pipe, so we are using this. Okay, here size you need to choose 700. Okay, no need of this specify local constraint here. Sorry, I made a mistake. If you want to go for 700 pipe, we can use it the catalog itself, like creating a separate catalog for 700 mm pipe. Go to components, conduit catalog, copy this 700 mm dia, paste it here, apply for design, 700 GRP. So this catalog now will be available. We can close it here. So go to catalog class. So all pipes are selected. In that catalog we need to change to 700. We didn't give name for that. Catalog, conduit catalog. So this is the 700 mm dia catalog. Rename to 700. Close this. Then here choose the catalog first, make it 700. So the size will be changed. Go to this, make it 700. This is material also we need to change. So what are the materials we are using, that we need to use it here. 700 GRP. So 3 things need to be changed here. After that close this, open the profile. So now we can see 500, 600, 700, 800, 800,000, 1000. So now it will be like everything will be in 700. Run all. This is how we need to change the conduit based on your needs. If you want to specifically change something to some one conduit, means we can use that catalog option. If you want to change something apart from the diameter, see, I need these 2 conduits need to be down, MH3 and O1. So we need a drop here. I need one drop here because my invert level is little bit lower. Don't consider this. My invert level is little bit lower, means what we done in profiling now, the same thing. Go to MH3 manual, MH3, set specify local constraint on. Need to go for the conduit, this one, M2 to MH, this one, specify local constraint on. So I need a drop like 0.5 something. I need a drop. Then what pipe I'm using here is 700. So I need to change the 700 slope also. I need a little bit steep. See, 600. We can use it here. If you run this, we'll be getting one drop after MH2. What happened? MH2, this is false. Actually the invert level will be changed. Previously there will be something bigger. I will change it. I will show it now. Go to this. I will turn on the specify local constraint off. I will run first. Whenever we are doing some changes now, we will just want to note what are the values previously, then only we can cross check it. See, the invert level is 3.2 right now. Okay, so after this we are going to make a drop here. So for that, click this conduit, go to specify local pipe constraint, true, part full design, ground to ground, minimum as 1.7. check this invert level 3.18 and 3.2. Validate it first. The link has adverse slope. So what happened to this file? First we will solve this error. This link has adverse slope. Four to six. 4 to 6. So what's the slope? The slope calculated is 600. For the dia, conduit discharge is above discharge, this and all nothing. So the adverse slope error gone. Okay. So what we are trying is we are trying to get a drop after MH2 here. Three point two, 3.19. Cover constraint is 1.7. The one drop should create here, but I'm not getting why it is not creating here after this. Otherwise simply we can create a drop like this by clicking here and reduce the invert level. First turn off the design structure elevation, then go to the invert. I need a drop of 0.5, so it is 34.3, 34.8. So no, we should minus 34.34. So see, the manual is created here until here. So then we can go to this start invert, get fixed to that invert, set invert to start. Then if you run means we will get a drop. So this is how we need to create a drop after the manuals, and So okay, now the profiling has been done, then how to use the local pipe constraint has been explained. So now we are going to move on to how to give the fixed load, then we will be winding up the session. Okay, so if you go to click on to the any node, there will be one option under the inflow wet collection. So go to here, click it here, click it, fixed load. Do you have if you have fixed, if you have, you don't have any load, any kind of hydrograph or any pattern you don't have, means you know just the value of how the load is. So we can give the fixed load here. So based on the fixed load, the conduit size will be varying here. Okay, meter cube per second. Okay, that's it. So I will be giving, see the pipe size first here. So the pipe size is about 700. We are fixed to 700. Okay, fix it to 700 itself. You can give like this. Before giving any load, I just want to show what's the difference is happening. No load is added. Go to conduit. Edit with all pipes. Make the catalog to all pipes. Then change to 315, so it will automatically run. Remove this one. So if you are selecting something, you want to analyze that part only, if you want to design that part only, we can select it, and we can after clicking the compute, it will ask to, like if you want to run for all things, if you want to go for selection, if you want to go with the selection set, it will ask. So like that we can select it and we can run. Profile. So this is the profile we are having a 700 mm. Starting itself it's from 700 mm. So what we are going to do is from the starting manual we will be giving some point load. Go to inflow wet collection, here add a fixed load like 500. We can give liter per second here for the units, 500 liter per second. So see how the pipe size will change here. If that flow is maximum beyond that pipe size only, it will change. If it is comes under the pipe size, it won't change. Okay, I feel 500 LPS is more enough to change the pipe size. So then run it. First check. First see this. This is in 700 mm. Starting 700, 700, 700, 800, 900, 900. See, so after we adding 500 mm on the manual one, so the inflow becomes more. So to accommodate that inflow, the pipe size has been increased to 1000, 1000, 1000, 1000, 1000, 1000. Like this we can use the inflow. So if you think like some other system is coming from this side, tools, box. Client is telling like some amount of water will be coming in the future from this side. The load is like about 500 lps. We need to connect to this manual, means we can give in this case we can give this type of point load and we can design the network for the future perspective. Okay, any doubts in this? So that's all for today. I hope everyone understand how to set up rational and how to change the things. So the next week we will be using the dynamic method. In that we will be adding the pumps, storage tanks, control sets, everything. If you have any doubts, you can ask. Yes, Abhinay.
Yes, today class, everything is good, but while doing the profiling after run the model, uh, I just can't follow it.
Okay,
But
okay, okay,
because
understood. Okay.
some of the parameters you turn true, false. Why we are doing that? That is not properly explained, I think.
Okay.
So if possible, in that why we are setting that invert is true or false, like if you explain that a little bit more,
Oh,
that will be more understandable.
okay, I will explain that part now. Just a small thing only. So if you go to any of the conduit, first understand this. So you are not doing anything. So the model have to design everything based on the design constraint which we want to set, which we have set already. Okay. So for in that case, we need to put the design conduit, design start inward, design stop inward need to be true. So based on the inflow, it will automatically take the pipe size and fix the ground to ground matching everything. Okay. So for that purpose, we need to use this true. Okay, Abhinay. So then.
Yeah.
Okay. Then if you are doing profiling, if you want to do smoothening the profile, if you want to do something like this profile is too smooth, I can tell it from here. Okay. If you want to do profiling, if you want to match ground to ground or something else, means this is like just a mathematics only. So this profile invert is here, this profile invert is here. So we need to match this, means if you minus this, means it will automatically match it here. So if you don't want to do that by manually, means go to this conduit manual 4 to 6. If you don't want to do any mathematical calculation manually, okay, in that case I'm telling, go to 4 to 6. So this is 4 to 6 conduit. So if you go to here in physical, there are multiple options are available. I will explain one by one. Conduit type, catalog, class, size. These and all comes from the catalog which we set. So number of barrels is like number of openings, kind of thing. That one. This is Manningsen, the pipe roughness. So set to start and set to stop. What this means is, if you take the conduit, this is the start invert. This part is the start invert. This part is the stop invert. If you take this conduit na, so this is start invert and this is stop invert. I am telling for the pipe. Okay, for the manual the invert is here. What I want to do is I just want to match this my pipe conduit stop invert to this manual, means I need to put true here. In this place I need to set invert to stop true. Okay, if you put also hit this profile, see this, if I set to start true, if I double click, so this will automatically match to this manual invert. So this is how we are matching it here. After putting set to start to true, if you run, means it will automatically design what the model wants to do, because here we have set design stop invert as true. So to avoid this, if you close this means, so it will automatically match to this invert. If I run the model means, so the conduit is connecting to that MH6 invert. So for this purpose only the set invert to start, set invert to stop is there. Okay. Okay, if you, another method is, if you don't want to do by COGEMs, you want to do manually. You want to do manually by connecting this to this. So in that case, what you want to do is you need to take this manual invert level MH4, which is 3.58 or 33.34. Below one, 34.48. If you minus this and place the manual here, means it will automatically match it here. So that one I will do now. 33.34, 34.48. $34.48. This minus this 1.14, we need to add it here. This is the invert of MH5, this one. We are going to add the difference here, 34.48. So go to the manual MH5, turn off the design structure elevation first, then go to here elevation invert. So what's the value? 34.48. Actually we need to minus 32.2. 32.2. This one is 33.34. 34.48. So here it went too deep here. Like manually we can check, means to match the slope it should come here 33.5. We can drop the manual first, then go to the conduit, turn off the design start, because design start need to be connected here in the bottom of the manual. Turn on this design stop. So if you are connecting the stop here, it will automatically connect to this manual. Based on that old profile will change. So here the depth is about 32.6. we'll see. Stop, then go to set invert start. So this is connected here. If you run means this whole thing will change. So this is because of we have closed the design stop invert and check in set invert to start. Because of that this one is like this. So go to conduit 10, 7 to 9. Make the design stop invert true, because we already dropped everything. So Based on that, everything will be changed. If you want to find out what are things are stop, invert, start and true or false, simply we go to this, click the profile, edit group, go to the conduit, design stop, invert, false in one of the conduit only. We'll check that. That is here. We'll run. So this is because of this design this design option is in false. So this is how it works, Abhinaya. Do you understand something? So if
Yeah,
you
yeah.
keep on practicing only, this will come. If you are looking for first time means it will quite difficult only. But if you are doing something one or two times means it will be more easy for you, for everyone. Anything from others? Praveen?
Yeah, it's all good. Okay.
Yeah, bro, you have the software, so you can try the chef. I have given the chef files also for you. So you try to get
Yeah, yeah, sure,
whatever I have done in this class and get back to me.
sure.
So in the
Okay.
next class, try to show the profiles.
Hello, Vin.
Yes, yes.
I got that student license for the
From Anna
software.
University?
So, yeah.
Okay.
So, can you
Yeah,
share that link?
today I will try to share everything as a zip file. So for your practice. So while doing the practice only, you can get it. So how you get that through your PhD student license or
Yeah,
first from someone?
yeah. Since I have submitted the thesis, I have time till the Viva voice. So the time I can access that. So getting that letter from our department, I just got that
Yeah.
license for water gems, sorry, sewer gems, and for info work ICL too.
Okay. Okay. Nice. That nice. Karthikeyan, anything from your side? Did you get anything? Do you understand? Hello. Actually, you are not audible.
Can you hear my
Yes.
voice?
Yes.
Sorry,
Yes.
I
Yes.
just okay. It's clear, but I need to practice it, and then I'll be come to know where I'm getting stuck. Then I'll
Do
ask.
you have this
Uh,
software?
what else. Yeah, same like student
Yeah. Okay. Okay. That's
version.
fine. That's
So I
fine.
have used. Yeah.
Akshata, Arini, anything from your side?
No, no issue, but I don't have software to practice.
Oh, in your company, what you are doing? What you do in
I'm using water
water
gems
gems
only.
alone?
Water gems.
Okay.
Yeah.
Okay, but software is available, but we need
I'm
license
taking
to
the
run.
course and practice.
Huh?
Okay. Okay.
Okay, actually, software is available in online, but we need license to run that. That's the issue.
Yes, sir.
Uh, if you want to practice, you can download it and turn off your net and you can use it.
Okay.
But you can't compute. You can't simulate the result. Simply, we can get the input, the files, and what are changes are happening. We can see, but the results you can't see.
Okay.
Harini, Vishal, anything? Do we need to change anything? Any comments from from all I'm asking. Is it fast or we are going slow? Okay guys, we'll see you next week. I will share you the videos of the two classes which happened this weekend, and the shape files for you practice also. So make sure the first study this manual. What are the things inside the stormwater is happening will be clearly explained in this manual. Understand the logic first. After that, everything is like mathematics only. Nothing big in the softwares. Everything is mathematics. Okay, guys. See you. Bye. Thank you, guys.
Thank you. Bye.
Thank you, Vinny. Bye.